Hello everyone, in this content we are trying to follow this book Cloud-Based Remote Sensing with Google Earth Engine, chapter A1.4, Air Pollution and Population Exposure. So this chapter is about the air pollution during the COVID times, and this chapter is very helpful for those who are interested in air pollution or who are interested in environmental monitoring in general. So we are introduced with Sentinel-5P data, and we are also introduced with the population data. So our objective is to go quickly through the course as much as possible, and there are many new things to grab from this chapter, and this chapter is very amazing. I have to say this because this is very applicable, and this is very much research-based kind of chapter. And let's go through the course. So this is the first section, and here we have a polygon, or the area of our interest, and this has been bounded by this geometry. This is the point, and this selects that specific polygon. So this is the way to select the area of interest. So if we do the filter bounds to the feature collection by the point, this will give that polygon. So that's just the new way to do that. Then we are centering it as the main thing in the map with the zoom level 8. And this map.set options, it's just the way to make that map appear with the levels. And then we are adding the area or the polygon as the layer. Then here we have the population dataset, and filtering has been done for 2020, and we get the dot mean image by dot mean. And this has been clipped to our area of interest. And then here we are adding this as the layer, providing minimum and maximum value with colors and also opacity. And finally adding this as the layer. Then we have the Sentinel-5P Yanoti product. And here is the cloud masking function, and then here we are selecting some bands. Before that we are filter bounding with our main area of interest, and the cloud masks has been provided. And then the specific selections of the dates has been done. So this main dataset has been filtered with 2 dates, so for a month, and the median image has been generated here, and then this is clipped to our area. Again, this has been added as the layer, and finally this is for the median image. So I have already run this, and what we see here is our main area of interest, that is this polygon here. So this is somewhere in China, the main epicenter of that virus. And then we have the population count image. So the brighter image meaning higher population, and then there is this median image of that concentration or that gaseous form. So let's say that gaseous form for now, but we have to understand the units of the bands. So I think that is the concentration here. Then here is the second section of the course. So this has the This has that window, the sliding window for the comparison of two different times, and also we see the chart here as I have already done this. So here again, this filtering has been done with the median image for these specific dates. Click to the area of the interest. So this is being done for 2020 and the 2019 for the same month, and then this UI.map has been used. So basically what has been done, just to skip through, the main objective is to get this one here, this slider. So left hand side will have something and the right hand side will have something. So this is for the quick comparison, and it is helpful for visual inspection. So this code is very much adaptable in many cases, and here this UI widgets are used for this purpose, and also there are ways to add the labels, and the new thing that I have to point here is this function here. So here we see this UI.chart.feature.groups, and this is kind of doing the same thing as that other function of creating DOI series in the image collection, but the difference is that it is doing directly in the images. So here we are filtering the main data, and then we are mapping this function. So this get conc is the function here. So this function gives the mean YANO2 for the study region per image in the YANO2 collection, and this has been done for 2020 and for 2019, and one has been renamed as lockdown and the other one as the baseline, and this has been added, this has been charted as seen in the console here. So what can be generalized is that during the lockdown, the concentration of YANO2 was very low compared to the other years or the normal years. So the baseline here is the 2019, but the lockdown or the 2020 has the lower concentrations. So this is the main idea. And in the section 2, just to say again, there are two things to learn here. The first one is this this window, the sliding window comparing two different images, and the other one is this one. Here we are charting this concentration along with the days of years. So for this, I believe there are other functions as well, specifically for the image collections, but here the new one is being used. So this is a very new thing to explore. Yes, here UI.chart.feature.groups. So please explore through these codes. Very nice way to do things. And the final one here is the section 3, and this section 3 shares us the concept of this concept called population weighted concentrations. And to brief about this is that we are not just dividing anything by the population. What we are doing here is that the population will have its role during the calculation of the density. So if some area has the small population, then it is given some low weightage, while as the areas which might have that larger population, so this will be given more weightage to that NO2 concentration. So that is the thing here. And here the very long function can be seen using 4 different parameters, and this function has been mapped here in this case. But again, the final result here is this one. So I will not go through this one because this is very long, and line by line careful understanding is needed for this one. But this section 3 has resulted this chart here, and so it is giving some importance to those areas where the population is higher, while as the in those areas where the population is low, not that much importance has been given. So that is the thing here. But to go through the section 3, the main thing is this function here, trying to calculate that population weighted concentrations, and that is applied to that NO2 collection, and this has been charted. So I would like to do this much for this chapter, because going through all these lines by lines are really challenging, so I would not like to go through them. But if you are very interested in this areas of pollution or environmental monitoring, this chapter is very much going to be helpful for you. So this much in this video. Thank you for watching.